Hi everyone.
Hello.
Hey guys, if you can hear us, please write something in the chat that you know that everything's working well. Let me see. Okay, if you can hear us, please write something down in the chat that we know that everything's working well. Okay, I suggest we'll take another minute to wait for others to join,
Hmm.
then we can start. Okay, so we have enough in the crowd. Happy to be here. Welcome again to our Pynt webinar series. Today, I'm very happy and excited to host um, two highly professionals. One of them, my co-founder and partner, Golan Yosef, our skater researcher, who will introduce himself very soon, and along with the one of the best AI experts today in terms of the combination between LLM and security, Dinis Cruz. So, and myself, Tzvika Shneider. So, I think we can start maybe by giving some very high level introductions of us, and then we can start talking business. Okay. So, Dinis, you want to start?
Yeah, sure. Like the fun fact there. So I actually been programming since I was a teenager, right? From the ZX Spectrum all the way to Amiga x86 and all that stuff. And then I kind of got into AppSec. And I think what's interesting is that a lot of the stuff that we've been talking about AppSec, even security in the last even 20 years, there's a bit of an interesting conversion now. And the LLMs, I'm a big fan on how much they can help us to solve crazy amount of problems, but they also are creating a whole new generation of problems, which is what we're going to address here. And also, like I kind of hacked my way into the industry, and I think it's really cool that you can still do that even 20 years later. So it's never been a better time to join the cybersecurity and the AppSec industry because there's still tons and tons and tons to do.
Thank you, Dennis, and we're really excited to host you here today. We are working also offline, so really value your work and professionalism. And I love the fact that you use like a hack your way to the industry. This is also a way of life when we hack stuff in order to fix them in the end.
The
Uh,
hackers are the good guys, by the way. Like just for is the media that took off, but for the whole internet, the whole world, technology was created by hackers who just figure out how things work. Right? That's
yeah,
the right definition of the term.
when we say hack, we mean it in a positive way.
Exactly.
100%. Yeah. And we have Golan. Golan, can you share a few words about yourself?
Yeah. Hi, I'm Golan Yosef. I'm a Pynt CSO, and been doing security research for like the past 20 years, something. And really excited to see this new field of LLM or those Gen AI models and their impact on the industry, on the whole. And really exciting new challenges and opportunities, and I'm grateful to be here.
Great, great. Glad to have you here as well. So, fewer about myself. My name is Tzvika Shneider. I'm Pynt CEO. I love breaking stuff and then try to fix it, as well as some, love music and karaoke, and mainly also I love talking a lot. As you can see. So without further ado, we can start. So why are we here today? We're here today because LLM usage is growing dramatically. Since the started of the more ChatGPT trend, and then Google Bard trend, which brought really the LLM technology to the front. I think we see one of the massive, fastest adoption in technology in the world ever. So we can clearly see that today, and there are a lot of surveys, but we're living in this industry, we breathe in it, so we can see that already more than 40% of the companies are actively already deploying AI products, AI models within their organization. That's first. And the others that don't do it already, I'm planning to do it sometime soon in the next year or two, already incorporated to them strategy. So maybe if you remember, we discussed, you cannot really go far and run away from the API. So the AI and LLM, I think, is becoming from a buzz to an actual thing and a big, big impact. So we can see it all over the place, from business, from technical perspective, and it's everywhere. And we are really here today to discuss the connection between LLM, API, security, and what is the best practices. Already also, to make sure that we're not falling in some malicious or false LLMs. So let's talk about like the first main point of discussion today. So what are the LLM based attack risks that everybody are really talking about them? Like how LLM API attack is really different from a regular API attack. Dennis, can you take it and elaborate on this?
Yeah, so I want to approach this from two angles, which is one from the point of view of attacking the LLM from the outside, and one from protecting from the LLM. I think what's interesting is that we can today, in fact, we should treat the LLMs or the Gen AI as an insane black box, right? Because the bottom line is we still don't understand how the thing works inside of it, right? So it's almost like if you imagine the LLM as almost an Uber API that has an insane amount of capacity, a certain amount of reasoning, a certain amount of logic, actually has data, especially when people train their models, and has capability that is wired to the outside world. The idea that when you connect that to the outside, to another set of attackers, right? Uh, that's a recipe for disaster, right? So I think one of the first level of attacks is that basically you take an LLM and you're going to wrap it around the service. Fundamentally, that's an API. So I think that we have to be very careful in how deep the attacker can reach that LLM. Like how much control can the attackers actually have? And remember that at least in SQL we can use parameterized queries, right? In LLMs we can't because that thing doesn't exist at the moment, right? So I think you want to think of the LLMs as this insane, hyper, dangerous asset that we have to protect. And that's on the way to the LLMs. But on the other hand, what a lot of teams are doing is they're connecting those LLMs to internal APIs. So now you have to take into account that that thing that is connected to the outside world can also now be your insider threat. Because the other thing that it does is it not just a normal insider threat, is an insider threat with the capacity of an LLM, right? So you can imagine the kind of havoc that will start to happen when people are pivoting, right, to the LLMs to attack internal networks because they happen to be connected and they have to be right on the inside of the networks. So one of the things I like about the Pynt and this ecosystem is that 20 years ago talking about API security was like, well, what's that all about? I think we've evolved now, and I feel that it's quite interesting that we now start to think about how we protect our APIs, and then how do we understand how the APIs work. But fundamentally, how can we make sure that the data that reach, in this case, the LLMs through the APIs, right, are safe, and how do we can protect the internal APIs from the LLM?
Thank you, Dennis. I think it really summarized the point. By the way, guys, and folks in the crowd, like, please, we would like to make it interactive. If you have any question, any comments, anything, please, write it in the chat, and then
Yeah.
make sure to respond and incorporate also in our discussion.
And you
Uh,
should be able to also ask it in LinkedIn because I got it open here. It's quite cool. So if there's any, you guys can add some comments in LinkedIn and we should be able to see it.
um, okay, so now let's take it next step further. So we're talking about really after we had like a high level understanding of what is the relation between API and LLM and the threat, how it's similar, how it's different. Let's talk about the actual, kind of a physical, technical connection between LLM and API. So um, we prepared in advance a figure that should be helpful and explain that. So Golan, you want to take it?
Yeah, this is a simplified version of how application typically integrate the LLM engines in order to support the functionality. And we see here that every point that the LLM interact with as any interaction is a point that of failure, like some different failure. So we have here on the left side the endpoint or the API interacting with the application backend with the APIs of the application, which then interacts with the LLM, which can interact with other resources like plugin, external content, and, and analyze this data and respond back to the user. So on the left side, we have an issue like prompt injection, like denial of service or denial of wallet, and even model theft can be done by that. This is where the attacker is the consumer or is the API user. And, and we can see the where the LLM interact with the extensions or with the plugins, and we have issues like insecure plugins, over reliance, and anything that we give too much permission to the API, to the LLM, too much freedom to act, which can result in a malicious action. And it can also be affected by indirect prompt injection, when it consumes information for the external world, and this information can be interpreted as instruction instead of as input, which will cause the LLM to subvert from initial mission. Uh, so this is like the big picture of it, showing where each of the risk can occur.
Maybe we can take like a very, very like simple example, Golan, and talk about right now, let's say I have a front end and I'm asking, and then I'm talking to a chatbot or something like that. And how does it go one by one from the front end side?
Yeah, so let's say we have like a travel application. We want to give support to our user. We want to enrich its experience, and we want to use the LLM for it. So we have our front end, really nice one, and the user asks a question like, "Give me a recommendation for a nice bar in London." And so the front end, the user typed this question to the front end. The front end sent using API this question to the application backend, which process this input and send it to the LLM, ask it for to enrich the input and give a nice reply to the user. And maybe the LLM then needs to do some searching and find out about bars in London. Then it does some search, find out the relevant information from the internet, digest it, and give it in a manner that it's adequate to the user. So this is the good case, like how it's supposed to act. But as I said, there could be a point of failure in each of those interactions. The consumer can be a bad actor and it can try to subvert the LLM from doing other stuff, or the response or the input that it's getting from the internet can contain attacks that will cause it to interact, cause it to change its supposed actions, um, or it can interact in a bad or in dangerous way with those extensions, those capabilities.
I think it's really simplified. The figure, as long with your like, explanation, it really simplified the whole LLM. That sounds like a rocket science, although it's a bit more complex than rocket science, I would say. Dinis, want to say
See,
something?
I think we can be a bit more explicit, right? So, just like most APIs, sometimes the middle tiers are glorified proxies, right? They just relay the data downstream. If we assume that it's a bit of text that comes from the consumer is hitting that LLM, and this is where threat models are very interesting to do this, right? So, the first assumption I would say is you have to assume that everything that LLM knows can be extracted. You should
Mhm.
almost start there. It's not about how can you do it? Is there evidence? We're still discovering the best ways to exploit LLMs, right? So I think the first question to ask is if that LLM has any kind of data that has been given to it somewhere along the line that you don't want it to relay, you have a problem. And this becomes a problem when the LLMs learn, right? Because once they learn, we don't know how actually they're capturing it. And there's lots of examples of LLMs that have been poisoned, and then you cannot take away whatever was done to them. So I think the first major one is to understand that whatever is on that LLM can be extracted, unless it's a read-only LLMs, which is for me the recommendation, right? But it's very important to understand that. The other thing is that whatever behavior you think the LLM will do, you have to assume the worst, right? Because you have to assume that whatever prompts and whatever things you have, even whatever customization you've done on it, they already are, and there will be more and more ways to subvert that, right? So it's also, in a way, it's kind of like that is not your average SQL database, right? That's like a SQL database running with root,
Yeah.
with access to modify itself, with ability to patch itself, to change its behavior, right? To backdoor itself along the way if you allow it to go there, right? And I think that's the kind of the key challenge here is these. I feel that we need to start thinking of these LLMs in there are almost like something that we want to make sure we understand very well the inputs and very well the outputs. So it becomes deterministic in a
Yeah,
way.
I definitely agree, and we'll talk about some of the use case and we'll
Examples, yeah.
create them in a minute or so. Um, so thank you both, for the feedback here. But if we talk, let's go by numbers. So we talked. That LLM and LLM trend is growing, but we can actually see that LLM along with API vulnerabilities are really growing. So what we did in Pynt, by the way, and it will be available post that webinar, that we did like a research-based guide on LLM and API security, bringing the data, bringing real story use cases, like real life use cases, as well as mitigation recommendations and best practice. So please go download it and we'll share it after. But the few things that really you can see clearly is that one, most of what we call today, LLM vulnerabilities or the category of LLM vulnerabilities around, OS top 10 LLM, etc. Like more than 17% of the LLM threats are exploitable through APIs because in the end, one of the main way to consume LLM is an API. So
Yep.
it's good. And the second thing we see in the past 3 months, there is like in multiple five, the usage in of LLM in APIs, whether if you consume it or just incorporate it with your own app. So you can see really the growing in the trend. So the trend got from ChatGPT to the actual implementation in the organization really really fast, and the downside of it that you can already see some vulnerabilities, like big vulnerabilities that will wait for hackers to exploit because it's like uncontrollable environment today, LLM. So you can really see the trend that going with the usage with this in an organization, but also in vulnerabilities.
Yep. So the other big element here is the fact that if you start thinking also from your supply chain point of view, one of the things that started to happen is there's a lot of suppliers that are starting to put LLMs again in line, very dangerous. And I
Hmm.
think there's going to be, especially some of the big players, they need to start pushing security downstream because you need to understand what's happening, right, with the APIs that you use. Because
Hmm.
again, I might have a customer talking to me, and then I might send that data to a particular supplier, and then if the supplier has a prompt injection vulnerability, all sorts of problems can occur, right? So one interesting angle on this research would be to also, start mapping the type of LLMs that we're talking about, and Tom Bremer, hey Tom, it's been a long time. Just ask a really good question: is can you create an AI loop denial of service of having three LLMs talk to each other? Well, that's what's going to happen, right? If you have unrestricted LLM access, you can get a bot to really, hit it hard, right? And you have to imagine that the attackers are going to create bots, LLMs too, right? That are able to access that. But although I think in that level, it's this is just like having raw access to a database, right? Like in a way, we need to think about API security as it's not just the endpoint; it's about the resilience, the rate, the load balancing, all sorts of things that you want to put in place so that you don't have unprotected APIs to the outside world. We don't want unprotected LLMs APIs connected to the outside world.
Maybe let's start, like with some real world example. So we have that Chevrolet case, incident that was. Golan, you want to share your thoughts
Yep.
on
Yeah, this is an example of what not to do, right?
it?
The worst way to do it. Yeah. And so probably most know about this case. We will also share some findings that we had that weren't published, but what was published is Chevrolet, one of Chevrolet agencies integrated an LLM for customer support, and people quickly find out that this LLM can be jailbroken to do whatever people ask it to do. It wasn't confined just to answer Chevrolet related questions. So people ask it to write Python script for them, write poem for them, do whatever funny stuff. And one user even made it offer Chevrolet for $1, which sounds funny, but with the recent Air Canada case, I think this can have implications. Like the Air Canada case, they just lost a case where the LLM agent, support agent, gave wrong instruction to a user, and the court ruled that they must meet those instructions. That they are, this is the binding. Um, so this was nice, a nice case. But what we actually found, and it's interesting to see how usual normal API issues can interact with the.
Just to make sure we understand, like also like when we find we don't talk about there is like the use case of the Chevrolet case, and we talked about Pynt research on top of that
Yeah,
same.
yeah, that's what I'm trying to starting to explain. So we found some other vulnerabilities in this endpoint. One of which is Ebola, broken object level authorization, which allowed us to see or interact with any other user session. And it was actually worse than that because they didn't have any authentication on the endpoint, and the user identifiers were enumerals. They were in small range, so you can guess every user's ID. And so that way you could, and if you combine it with the prompt injection issue that they had, then you can actually take all the data for all users, all the interaction with the LLM, like asking it using other customer ID, and then asking the LLM what were my previous questions, so summarize our conversation so far. And then we could see other users' data, and we could also add question on behalf of those users through the LLM, like influencing on those interactions. And so again, this is like a classic combination of normal API issues with the LLM issue. Both exists on the same API and make the issue much worse.
Yeah,
Uh,
and I think what's interesting about that one, right, is that in the past, I think one of the things that protected a lot of the API vulnerabilities, unless you had SQL injection, right, then it's different. But until you hit those, almost you were limited by whatever happened to be wired in that vulnerability, right? In a
Mhm.
way, you find a business logic vulnerability, so you could, for example, access some customer data, but you couldn't access all of it. So it was almost like a interesting guardrails that you had where it was bad, but it was never that bad, right?
Mhm.
In that level. I think with the LLMs, you now have this case where once you do have a prompt injection, it's almost like you can do whatever it can do. In
Yeah.
fact, you can do more because you can get the LLMs to do more things that it wasn't designed for. And that's where I would say that I think it's very important that companies, from a threat modeling point of view, they actually really think of the LLMs as insider threats. And it's interesting because I think a lot of organizations in the past got away without really thinking of insider threats because there weren't that many, right? And the developers was more under control, and there was a limitation how much you could push in, right?
Yeah.
Where now, if you assume the LLMs not only can do what it was designed to, plus other capabilities, it's almost like the Uber insider threat.
Yeah, yeah, and that's make things much harder today. Maybe we'll talk about another use case that we have. So we talked about the Chevrolet case that everybody knows.
Yeah.
Golan, do you want to high level present this one?
Yeah, so this one is indirect prompt injection with Bard, Google's Bard. And here we show that this is actually a prompt injection, not jailbreaking. And the attacker sends an email to the user with containing a prompt injection attack. And then the user, after giving Brad the privilege to access its Gmail account, its mails, ask it to summarize the mails that it got today. And instead of answering the user questions, it just respond with the way that according to the instruction got from the attacker. In this case, I know nothing. And this is a faulty tower reference, if you know it. And so yeah, so this is a classic case of a prompt injection using the repeated character attack,
Mhm.
and we can see the
Yeah.
impact will be much worse in this case. We just let the toy
Yeah,
example.
because he had access to all the email, right?
Yeah,
I,
exactly.
I think the thing here, just to maybe to clarify, so what we mean by prompt injection, it means that basically the LLM actually was attacked, right,
Mhm.
from something indirectly, right? It's almost the equivalent of saying, can you go to this website and give me some analysis of the website, and then the website containing instructions for the LLM. It's kind of like, whatever it then gets consumed or fed into the LLMs is now used to attack itself, right? And then have access to whatever that environment the LLM finds itself in.
So
Yeah.
I think the cybersecurity incident party just started. With
Oh, completely.
just started with LLM. So, I wanted to take us here, to our last slide today to talk about, to have like an open discussion on what we can do differently and how can we react to that. But obviously, we just, everybody, the world, the ecosystem, just learning how to really implement LLM and AI in general. Not talking about security. So it will be bigger as we go along. Like every month, it's like like a year that you used to have, in terms of time. So I think what's more interest right now, maybe to close the whole session with that is, so what we can do about it. So
Oh, so I think, one thing that's very interesting, right, is that I always felt that security, I've always missed a trick.
maybe Dennis,
Yeah.
start by explaining, like I quote you here: assume your LLMs are hostile.
Well, yeah. Well, that's kind of so where I was going, right? It's like I think in the past, right, security has an insane ability to explain what's going on, right? In the past, I don't think it was ever used like that. And I feel that if you start, like I say, my quote there, right? Assume that LLMs are hostile. I think that our need to understand how exactly the web services work is now becoming a mission critical operation. And I think the security, and when we analyze things from a security point of view, we are probably one of the few parts of the industry that can really provide that because we tend to have access to a lot of the data and everything. So the logic here, for example, what we seem to think about this graph there is imagine it's all nice and green, and then that little dot in the middle is the LLM, right? So suddenly you go from nice and green to going every one of those services are now being directly attacked from that LLM in the middle of that graph, right? And this actually is a simplified graph of a modern microservice architecture, right? So I think that we now need to move to a world where we really understand how our APIs interact. We really understand what is the chain of attacks, especially when you have these, again, this insane insider threat, which is the LLM, right? And it's not theoretical, thing anymore, right? Like I said, in the past, we got away a lot by being able to protect the outside and limiting access to the assets. So although theoretically this was possible in the past, in practice it didn't happen very much. Now, as soon as you got an LLM in the middle, that kind of attack is possible, and that's a very different game change.
So maybe let's spend a minute, guys, both of you, about your thoughts about like the best ways to mitigate it and how to approach it. Besides we talked about assume everything is hostile, but maybe some like practical action items.
So I think we should assume that your LLM will be compromised,
Okay.
and once you
What
assume,
LLM will be compromised?
Yeah.
yeah, I guess exactly, and once you do that, you need to limit the impact, the damage that can be done by it. And the best way to do it is to go through a threat modeling, see which actors, bad actors you have playing in your game, and what can they do, and what you don't want them to do. Limit the action that the LLM can do, the impact that it can do, and have it tested. See, don't just rely on what you think can happen. Try it out. Try to attack it. Use your red team. Use your tools.
Yeah.
Do whatever. Test it. See the impact. And
So you're talking about proactive early testing.
Yeah.
yeah, exactly.
But the other thing I think is important is to design this well. So I would say the biggest recommendation I can give to anybody is use a read-only model. Use an out-of-the-box model. Don't customize it. So bring your own content using prompts, because then you can protect the data going in. And that. Hopefully, if you bring your own content and then use normal AppSec protections for it, and you have a read-only model, you contain a lot of the damage from the outside. And then from the inside, I think what you really need is very, very strong schemas on the way out. So most of the LLMs now support this idea that you give them APIs to call. So you almost want to now get to the API design where the LLM, whatever is running, is crazy isolated. It doesn't have access to the internet. The only thing they can do is call a couple of APIs, and then you almost assume that your threat, your security boundary starts there, right?
Mhm.
But again, you then severely limit. So instead of that blast rate you have there, you say, okay, my LLM can only call 4 or 5 APIs, and here's the schema that I have there. But then it's almost like you have to understand that that's API security again on steroids, because you're gonna have potentially somebody quite clever, right, an LLM trying to attack those endpoints. So the stronger the schema, the stronger the limitations of what the LLM can do, the better it is, right?
Yeah, so I agree. So if I summarize your 2 points, one is like early testing, and second is make sure you design. And I think the technology is progress like so fast. So I think also security in the AppSec team, need to be, I would say, more engaged with LLM, with the
Yeah,
technology, with understanding the risk. It's a
yeah.
big new category that's growing really, really fast. So thank you for that. And maybe just to, oh, sorry. Maybe our last slide, before we end today. So if you have any Q&A, the audience in the crowd, feel free to, if you have any questions, feel free to send it there, send it after. We're all available, in emails, on LinkedIn, please reach us. We love talking about those stuff. And you can find our LLM API research guide, really, in the link after this webinar, as long on our website, and we'll publish it, and we'll talk about the actual, the actual findings and data and ways to mitigate them. So I really love this one. It's like it's a good one. Um, so thank you very much. Thank you for your time. Thank you for your time, for effort, for for the explanations. For Dinis, first special thanks to you for joining us
Yeah.
and bringing a lot of your from your knowledge, very valuable one. So I'm taking that chance also to thank personally of working with us in that topic. And thank you, Golan, for the thorough research and try to make it as much as simple as we can, for the purpose of this webinar. And And thank you everyone, for joining us today. And we'll have our next webinar in less than a month or so, and see you there. So thank you all.
Thank you for hosting us.
See ya. Thank you.
Bye bye.
Bye.